Welcome to The Explainer. Today, we're diving into the world of robotics. But our guide isn't some dense engineering textbook. No, it's actually a fourth grade quiz. And what's so cool is how these simple questions, meant for a 9-year-old, can give us this incredibly clear roadmap for how pretty much any robot works.
So let's just jump right in with the biggest question from the quiz. What is the single most important part of a robot? Think about it for a second. Is it the motors that make it move? Its hands? The battery? Let that question hang in the air for a bit.
All right, so here's our game plan. We're going to explore the robot's anatomy in 6 parts. We'll start with its command center, the brain. Then we'll get into its senses, its muscles, and the skeleton that holds it all together. After that, we'll see how all those pieces work together, and finally, where we see these ideas out in the real world.
Okay, first up, the command center. You can think of this as the robot's nervous system. And you know what? We're going to go ahead and answer that big question we just asked.
And the answer is the brain. Yeah. According to our 4th grade guide, the brain is, without a doubt, the most important piece of the puzzle. It's the director of the whole show, the boss telling every other part what to do and when to do it. So what does that even mean? A robot brain? Well, it's the central hub. It takes in information from the outside world through sensors. It processes that information, thinks, and then it sends out commands to the motors to make the robot do something. Without that brain, you've just got a fancy-looking pile of parts.
And this is where it stops being a mysterious idea and starts being a real physical thing. It's not some magic box. It's a hub with very specific plugs for very specific jobs. Our guide points out that it has exactly 4 ports for motors and 4 for sensors. It even has a special symbol for where the power connects. It's a real piece of hardware, kind of like a central switchboard for the entire machine.
But, a brain is totally useless if it's just flying blind. It needs data, it needs information. And that brings us to part 2, the robot sensory system.
Which leads to the next logical question, right? If the brain is making all the decisions, how on earth does it know what decision to make? How does it know if there's a wall in front of it or if there's an object it's supposed to pick up? The answer is sensors. Simple as that. They're the robot's eyes, its ears, its sense of touch. They're out there gathering all the raw data about what's going on around the robot. And, as our source makes really clear, they plug directly into one of those 4 sensor ports on the brain, using a connecting cable, feeding it that constant stream of information it desperately needs to do its job.
Okay, so a brain that can sense things is great, but it isn't really a robot until it can do something with that information. That brings us to the muscular system, the parts that actually create movement.
And when you boil it all down to the absolute basics, our 4th grade assessment says there are really just 2. 2 fundamental types of motors that drive almost every action a robot can take.
And the most important thing to understand here is the trade-off. It's always about speed versus strength. On one hand, you have high-speed motors. Think of those for quick, zippy robots, ones that need to move fast or maybe even fly. On the other hand, you have high-torque motors. These are the power lifters. They're for robots designed to do heavy lifting, where pure force is way more important than how fast it gets there.
So now we've got the brains, the senses, and the muscles. But what's holding this whole thing together? Well, let's take a look at the robot's skeleton, its structural foundation.
And I love this quote from our source because it makes a really important point about building robots. You don't just stick things together. The quiz is super specific about this. Robots are built for strength. That means you use things like nuts and bolts to join the metal parts, and it actually points out that something like glue, that's not the right tool for this job.
Let's look at a perfect, simple example, putting a wheel on. The quiz breaks it down for us. First, an axle connects the wheel to the motor. Okay, simple enough. That axle needs to be able to spin freely. But to keep it from just sliding out, you use an axle lock to hold it securely in place. See? It's a simple, really elegant system of parts that fit together to create reliable movement.
So, we've looked at all the individual pieces. We have the brain, the senses, the muscles, the skeleton. Now, let's put it all together and see how these parts come together to create a single, purposeful action. And here it is, the whole chain of command, from start to finish. It's actually a beautiful sequence. It starts with sense. A sensor detects something.
That data zips over to the brain to think. The brain makes a split-second decision and sends a command to act. The motor gets that command and turns an axle to move the wheels. Sense, think, act. That is the fundamental loop of literally all robotics.
So we've basically built a robot from the ground up, piece by piece, just based on these core ideas. Now let's connect this simple little model to the incredible machines that we see all around us every day.
You might be thinking, okay, this is all a bit basic. What about the super advanced robots of today? Fair question. Where do these fundamental building blocks actually show up?
Well, the answer is everywhere. Our source points to factories, hospitals, and even our homes. And think about it, while a surgical robot in a hospital is obviously way more complicated than the little guy we just built, it still works on the exact same principles. It has a brain, it has sensors to see, it has motors to move its arms, and it has a physical structure holding it all together. The foundation is absolutely identical.
So there you have it. From a simple 4th grade quiz, we've learned that every robot, from a little toy car to a life-saving surgical arm, is built on the same core ideas: a brain, sensors, motors, and a skeleton. It's a simple blueprint, but it's incredibly powerful. So now that you know the building blocks, what kind of robot would you build?